Hello everyone. So in the last lecture, we discussed the Bohr's model. This Bohr who gave the energy level concept, who gave the shell concept, but there were few limitations of the Bohr model also. And now today we are going to discuss the two topics which also resulted in failure of Bohr's model. So these two topics, the first one is the de Broglie wavelength. De Broglie wavelength, a small but important topic for both school level as well as JEE level. So de Broglie wavelength. What is de Broglie wavelength? कि एक m मास का पार्टिकल it also contains a particle also has a wave nature. So m mass का particle it also has a wave nature. It also has a wave length. M mass particle, it also has a wavelength, and that is known as de Broglie wavelength. But this wavelength is different from the wavelength of electromagnetic radiations. These wavelengths, the de Broglie wavelength, it is related to a particle. It does not carry energy. Where the particle moves, it only shows the movement in that direction only. So this de Broglie wavelength, the scientist de Broglie wavelength, he discovered the wavelength concept from the photon. The photon, it, according to Einstein equation, E is equal to mc square, and from the electromagnetic radiation, E is equal to hc upon lambda. So now relating these two, mc square is equal to hc by lambda. So from where c cancels, and lambda is equal to h over mc. Or lambda is equal to, if a particle is moving with v velocity, the de Broglie wavelength is h over mv, where m is mass of the particle, v is the velocity, and h, as we already know, it is Planck's constant. So m, mass of the particle, and v, velocity of the particle. So this is de Broglie wavelength. But the de Broglie wavelength, it is only valid for the subatomic particles, the proton, the electron, the neutron. These particles, they are known as microscopic particles. These particles are known as microscopic particles. So microscopic particles like proton, electron, neutron, atom, molecule. So only for these type of particles it is applicable. To the macroscopic particles, what are macroscopic particles? Like cricket ball, golf ball. For them, why it is not valid? So first we calculate using the formula a wavelength for a cricket ball or a golf ball. H over mv. So H is 6.626 into 10 की power minus 34. Let us suppose, what is the mass of a cricket ball? The simple tennis ball. Let us take mass 100 gram. In kg it will become 100 upon 1000, 10 की power minus 1, and velocity again 100 meter per second. So the wavelength of a ball, it comes, this becomes minus 33, and then 100 makes it in terms of minus 35. The wavelength of a cricket ball is very, very small. We cannot observe them, it was not possible for scientists to see such small wavelengths. That is why they are not valid on the macroscopic particles. Now, wavelength of an electron, so H, it remains same. The mass of the electron is, yes, 9.11 into 10 की power minus 31, and the velocity of the electron, again we are taking suppose 10 raised to power 100 ही ले लेते हैं, so it will give you a more better comparison. So it becomes 10 raised to power minus 34 and minus 31, it becomes only minus 3, और नीचे से दो जीरो आएंगी, so it comes in terms of 10 raised to power minus 5 or 10 raised to power minus 8. So these values which we have already discussed, picometer, nanometer, this wavelength it lies in nanometer, picometer, so which were observable. This de Broglie wavelength concept is valid for microscopic particles, the fundamental particles of atom. Make the notes. De Broglie wavelength, the formula is lambda is equal to h over mv. So now, how it is affecting the Bohr's model? How it is affecting the Bohr's model? When, according to Bohr, the electrons are moving in a straight motion on the circular orbits, on the circular path. But according to de Broglie, when electron moves on its shells, on its energy level, then it forms a wave, a closed wave. Okay. Electron motion is also has a wave nature, and the waves, they are closed in shape. Okay. A complete number of waves lies in the path of the electron, and there is an NCERT question. Show that the circumference, question number 32, show that the circumference of the shell is integral multiple of de Broglie wavelength, integral multiple of de Broglie wavelength. So what is meant by the question? पहले आंसर समझते, then we will understand the question also. कहीं कहीं पे उल्टा होता है, पहले आंसर समझ आएगा, then we will be more clear with the question. So, according to orbit angular momentum, the last class, last में orbit angular momentum, नहीं यार तो प्लीज गो एंड वॉच अगेन. mvr is equal to n h by 2 pi. The orbit angular momentum is also quantized. So mvr is equal to n h upon 2 pi. So 2 pi इधर आ गया. 2 pi r is equal to n into h over. So 2 pi r is equal to h over mv को लिख दिया de Broglie wavelength. So the circumference of the circle, the circumference of the shells is integral multiple. It is whole number multiple of the wavelength. The first shell can have one wavelength. The first shell is covered with only one wavelength. The second shell is covered with two wavelengths. The third shell is covered with three wavelengths. The first shell, one wavelength. The second shell, two wavelength. Third shell is covered with three wavelength. The circumference is integral multiple of the wavelength. एक तो ये क्वेश्चन आता है और क्वेश्चन कैन बी रिवर्स्ड ऑल्सो. The question can be reversed. To show that, prove that the orbit angular momentum is the integral multiple of h by 2 pi from the de Broglie wavelength. तो इलेक्ट्रॉन का पाथ, इलेक्ट्रॉन का मोशन is not a straight on the circular path. कि वो बिल्कुल एक स्ट्रेट एक पाथ पे नहीं घूम रहा. इट हैज अ वेव नेचर दैट इज शोन बाय द de Broglie. इसके बाद now we are doing one example. So NCERT question number 20, 57, 58, 59, 60, all are based on de Broglie wavelength. Calculate, एक different question करते हैं. Calculate ratio of de Broglie wavelength. Calculate ratio of de Broglie wavelength of oxygen to sulfur dioxide molecule moving with same velocity. Moving with same velocity. कि एक ऑक्सीजन का मॉलिक्यूल और एक सल्फर डाइऑक्साइड का मॉलिक्यूल, इन दोनों की डी ब्रोगली वेवलेंथ का रेशियो. तो H ओवर mv, H ओवर वेलोसिटी सेम है, H सेम है, बस डिफरेंट इज ऑफ मास. तो इन दोनों का रेशियो बनाएंगे विच कम्स कि लैम्डा ऑफ O2 बाय लैम्डा ऑफ SO2 इज इक्वल टू H कैंसिल, V कैंसिल और रेसिप्रोकल होके M mass of SO2 on the numerator and O2 denominator. So what is the mass of a SO2 molecule? Sulfur 32 and O2 is also 32. So 32 plus 32 64 and mass of O2, it comes to be 2:1 ratio. So these are MCQ type questions. It can be in MCQ also, it can be in subjective also. This is de Broglie wavelength. Clear? And then in some questions, instead of velocity, kinetic energy is given. कि de Broglie wavelength in terms of kinetic energy. Sometimes in place of velocity, so kinetic energy is equal to half mv square. So v is equal to 2 kinetic energy by m और उसका स्क्वायर रूट. And de Broglie wavelength lambda is equal to h over mv. So we will substitute v by under root 2 kinetic energy over m और साथ में this m is out of the root. और अगर हम इस m को स्क्वायर रूट के अंदर ले जाएंगे तो it will become h over under root 2 kinetic energy m square by m. So 1 m cancels and the de Broglie wavelength in terms of kinetic energy is h over under root 2m kinetic energy or 2m e. NCERT question number 21. Second chapter question number 21 is based on this formula. This is your homework, try it yourself. So this is all about the de Broglie wavelength. And the second topic, which also fails Bohr's model, is Heisenberg uncertainty principle. According to it, it is impossible to find or to calculate the position and momentum of an electron with complete accuracy simultaneously. इलेक्ट्रॉन एक इतना छोटा पार्टिकल है कि उसके पोजीशन और मोमेंटम दोनों को एक साथ एक्यूरेटली मेजर करना इज इम्पॉसिबल. एक इलेक्ट्रॉन, scientists, how they discover the position, the momentum, they makes use electromagnetic radiations which strikes with electron and then they come back and give the position of the electron. But electron is a very small particle कि अगर हम उसकी पोजीशन को एक्यूरेट करते हैं, फाइंड करते हैं, तो जैसे ही इलेक्ट्रोमैग्नेटिक रेडिएशन इसको हिट करती है, देन इट्स मोमेंटम चेंजेस. When electromagnetic radiation hits the electron, then we get the position, but the momentum changes, and if we try to accurate the momentum, then the position changes. So delta x and delta p, these two symbols are used in the formula where delta x is error in position and delta p is error in momentum. And according to the Heisenberg's uncertainty principle, delta x dot delta p, कि वो एरर या तो h बाय 4 पाई के इक्वल होगा या उससे ज्यादा होगा. कि एरर तो आना ही आना है. द एरर इज डेफिनेट h बाय 4 पाई और ग्रेटर देन h बाय 4 पाई. This is this is Heisenberg's uncertainty principle. और इसी फॉर्मूले को इन टर्म्स ऑफ velocity, the delta v, error in velocity की mass momentum is equal to mass into velocity. So delta x mass तो चेंज हो नहीं सकता, so error in velocity is greater than equal to h by 4 pi, and the formula becomes delta x dot delta v is greater than equal to h by 4 pi m. और in numericals greater than की जगह we can use only equal to symbol. So this is Heisenberg's uncertainty principle. इलेक्ट्रॉन एक स्ट्रेट एक पाथ पे नहीं घूम रहा, it has a random motion, it is moving in a random motion, it goes out of the trajectory that is given by Heisenberg's uncertainty principle. So it also leads to the failure of Bohr's model. So now the Bohr's models also get failed. Electron is not moving on a circular path, but electron has a wave nature. Electron is moving in the same form of a wave in a random motion, and that gave lead to the orbital concept. So with this we have already seen. So this is what orbital concept. The electron is moving in a 3D path which are known as subshells and orbitals. So they link. तो इस पे पहले से ही वीडियो बन चुकी है, so I will giving you the link. You may go and check and then complete the chapter. इस चैप्टर में अब इसके बाद फेलियर ऑफ बोर के बाद ये पूरा टॉपिक आता है the present form of the atom. So this is what is the present form. So let us do an example on Heisenberg's uncertainty principle. An electron is moving with with 1 by 10 speed of light. If error in velocity is 4%, if uncertainty in velocity or error in velocity is 4%, then find error or uncertainty in position. So what is the speed of the electron? Speed of electron V is 1 by 10 of speed of light, 1 by 10 of 3 into 10 raised to power 8, which is 3 into 10 की power 7 meter per second. And error in velocity delta V is 4% or plus minus 4%. So delta V is 4 by 100 into 3 into 10 raised to power 7. So this becomes 10 raised to power 5. So 12 into 10 raised to power 5. This is delta V, and we have to find error in position. So delta x dot delta V. The velocity की terms में there was m. So delta x into delta V, 12 into 10 raised to power 5 is equal to h, 6.626 into 10 raised to power minus 34 divided by 4, pi की value 3.14 into mass. So mass again electron. So mass of electron 9.11 into 10 raised to power minus 31. So this will give us the delta x. An electron is moving, so this is how the numericals are based on the Heisenberg's uncertainty principle. And then there is one more conceptual question. What happens? What happens to the uncertainty in momentum? What happens to uncertainty in momentum? If position is measured accurately, if position is measured accurately, position is measured accurately means delta x कितना आएगा? delta x क्या होगा? There is no error in position, delta x is 0. So delta x dot delta p, Heisenberg's. So delta p is equal to h by 4 pi into 0. कि अगर एक चीज को एक्यूरेटली मेजर किया तो दूसरी चीज इट गोज इन इनफाइनाइट एरर. पोजीशन को एक्यूरेटली मेजर कर लिया तो मोमेंटम गोज इन इनफाइनाइट एरर. और मोमेंटम को एक्यूरेटली मेजर कर ले तो वाइसा वर्सा, पोजीशन गोज इन इनफाइनाइट एरर. ओके, क्लियर? This is all about de Broglie wavelength and Heisenberg's uncertainty principle that led to the failure of Bohr's. And then there is concept of shells, subshells. So this is all about today. Thank you so much. So my name is Saurabh Roda, and please subscribe, like, and give your comments, and also share on WhatsApp if you like the video. Thank you so much. Signing off, Chem 3D Mind Catalyst.